Okay, so let's look at number 6. All right, guaranteed that one's on the test. Okay, I remember seeing it this morning when I was looking at the test. So, we're going to use our cofunction identities to evaluate the expression without a calculator. So the key was making sure we got things to add up to what? 90. Okay, so we want to find the angle measures that pair to 90. So what's going to pair with 41?
49.
So I'm going to just rewrite it. You don't necessarily have to do this, but this is the way I showed you how to do it when we were going through it. And then 79 would pair with what? 11. And notice those are both minus, right? So minus cosine squared of 79 degrees minus cosine squared of 11 degrees. All right. We are allowed to, the cofunction identities, remember the third window, first column. We are allowed to replace this with the sine of the opposite angle, right? So cosine squared of 41 degrees plus is the same, and cosine squared of 49 is the same as sine squared of 41. Cosine squared 79 degrees. Cosine squared of 11 degrees is the same as sine squared of 79 degrees. Okay? Before I go any further, I'm going to look at this back part, and I'm going to factor out a negative. So now I've got cosine squared 79 degrees plus sine squared 79 degrees. So your key to be able to use in the Pythagorean identity is, first of all, it has to be a plus sign. Okay? And then these two numbers in here have to match. So what's sine squared plus cosine squared equal to? 1. What's sine squared plus cosine squared equal to? 1. 1 minus 1 is?
0.
There's not many possibilities you're going to have on this. It's going to be 0. It's going to, if you're subtracting, it's going to be 2. It might be 3 if I do 3 pairs, right?
Yep.
Okay? So it just depends on how we put it together, but you're basically, your key is looking for the 90s, and then making sure you pull out a negative if there's a negative in there, and then sine squared plus cosine squared. Okay? All right. Lauren, you get to pick the next one.
11.
11? Okay. All right. So we are verifying the identity. Okay? You have to show your steps in between, right? So what am I going to factor out of this left side here? I'm going to factor out a secant squared. Okay? So what's left behind? Tangent squared x plus 1. I want you to look at your Pythagorean identities on the windows. What am I allowed to replace tangent squared with? Tangent squared plus 1 with?
Secant squared.
Secant squared. What's secant squared times secant squared? Secant to the 4th x. Did I get what I wanted? Yes, these two steps in between is what you're getting your points on. You need to write them both down. Okay? All right. Let's see. Alexis, what do you want to see? 15. All right. Let me make sure let me pull up my answer key because I didn't do that. Make sure I do it right. 12. Oh, wait. Is that your 15? Make sure we're on the same.
No.
That's not your 15?
That's 14.
Okay, 15 is the next one. Yeah, because I know the numbering got off a little bit. That's 14. It got off at 12, right? So 15. All right, so what you have to do on this one is we're going to peel off whatever's back here. Okay, that's the key to doing this type. So instead of, I'm going to break this into, if I have to put a cosine cubed at the back, what is it going to break into? Cosine what and cosine what? Cubed. I know it's got to be cosine cubed back here. What would it be up front to get back to 5?
Squared?
Squared, yep. So cosine squared and cosine cubed. I know I'm allowed to replace the squared. I want to because I need to get it into sines. So I need to use my Pythagorean identity. What's the Pythagorean identity for cosine squared?
Cosine squared plus sine squared.
No. Look, you guys look up at the signs. What does cosine squared equal?
1 minus
1 minus sine squared x. All right, to get it in this format, what do I need to do with this? Distribute it. So we've got sine squared x minus sine to the what? 4th x. And then the cosine cubed is just going to hang out outside because that's what it looks like here. Again, the 2 steps in the middle is what I'm grading. We got what we wanted. That's right. All right. Caesar, which one do you want? 14? Okay, so we're going to go back one here. So everybody, that's your 14, right? Okay. So I am going to choose to work with the left side. Okay? I know what I can do with the denominator. I'm allowed to do conjugates of denominators, whereas this one, there isn't much I can do with that denominator. So I'm going to go for the conjugate of that denominator. So cotangent of alpha over cosecant of alpha minus 1. So what is the conjugate of cosecant alpha minus 1? Yep, cosecant alpha plus 1. Cosecant alpha plus 1. In the numerator, I'm going to choose not to distribute. Cosecant alpha plus 1. In the denominator, I'm going to FOIL, but what am I really going to do in the denominator? Do I need to do all of FOIL? First and last only, right? So it's cosecant times cosecant. Cosecant squared alpha. What's negative 1 times positive 1? Negative 1. All right, this looks kind of Pythagorean to me, so look up at your Pythagorean identities. What can I replace that with? Cotangent squared, right? Alpha. I'm going to let you guys catch up. All right, so my see how I can take this cotangent and take one of those out that's in the denominator? So then I'm left with I'm sorry, my handwriting got really bad there. Cosecant alpha plus 1 over the cotangent of alpha. Did I get what I wanted? Yes, we got what we wanted. These steps in between are what I'm going to grade. Steps in between are what I'm going to grade. Okay, let's see. Caesar got that one. Let's see. Maria, you get the next one. 21. 21? Okay, so 15, 16, 17, 18, 19. Is that your 21? No? Oh, did it go back? Is this your 21? Let's make sure I've got the right problem. No? That one? Okay, so there's 21. Apparently I got another one that I took out from a couple years ago. Okay. What are we going to do? So I got to get everything off of the trig piece first. So what am I going to do to move the square to 3? Add it. Remember, you do get to use your unit circle tomorrow. I will be checking them for extra stuff on them, so don't write anything extra on them that I haven't told you to write on them. All right, what am I going to do to move this 2? Divide it. So sine 2x equals square root of 3 over 2. All right. I need to go to my unit circle. Is sine the x value or the y value? Okay, so on your unit circle, what radian measures have the y value of square root of 3 over 2? Pi over 3 and 2 pi over 3. Good. How do we get this 2 to the other side? Divide by it or multiply by? 1/2. So you get x equals pi over what? 6. Here on this one, the 2's would cancel, wouldn't they? So you get pi over 3. All right, Lizandra, what do you want to see?
23.
23, so that's 21, 22, 23, this one? Okay. So remember, I didn't do the nice automatic test like we did last time, right? So you're going to list your answers in order, okay? And you're just going to list the letters. I'll write out at the end what it should look like, all right? So what is the one that looks exactly like the left side? E, right? So we would have E, and it's 1 minus tangent to the 4th theta, okay? I have to figure out what would go next, okay? So I'm going to factor that, right? That's factorable, isn't it? So let's see what happens when we factor it. So what do I get? It's a difference of squares factoring. What do I get when I take the square root of 1? 1, okay? And what do we get when we take the square root of tangent to the 4th? Tangent squared theta. And we make 1 a what and 1 a what? 1 a minus, 1 a plus, right? And if we do it in that order, look at which letter choice is it now? D. Okay? So we know we've taken care of, let's see, we've gotten rid of E, we've gotten rid of D. Those are the two we've used, right? Okay. And this one's a little bit weird. I have to figure out what I can replace one of them with. So if we're looking up there, okay, I know I can turn tangents into secants, can't I? Yeah, so but I need to get this step by step here. It looks like I'm going to change both things, doesn't it? I'm looking at this one right here. Let's see if we can get that one right there. Because this one, there's something going on. Maybe that's the next step, okay? So I know I can replace tangent squared with what? Not secant squared. Look up at the signs. What do the signs say for Pythagorean identity? Secant squared theta minus 1. Okay? What can I replace 1 plus tangent squared with? Do you see the difference? So this one I just was replacing tangent. I had to use secant squared minus 1. This one I was replacing 1 plus tangent. I just get to use secant squared. Is that A? Yeah. Okay. Thank you. All right. All right. Then what do you think I'm going to do with this negative sign here? Isn't that what part C is about? Yeah, so C is 1 minus secant squared theta plus 1. Do you see how we're showing every little step? Okay, we didn't leave anything out. All right. What happens now? Can I do some combining here? Okay, so what is 1 plus 1? Oh, I don't know why I'm writing D. 2 minus secant squared theta times secant squared theta. Is that one of our choices? Yeah, which choice is that? J. All right, and then we've gotten J in there. We've taken care of those two. All right, what am I going to do now with this secant? Distribute. Okay, so my final one should be 2 secant squared theta minus secant to the 4th theta. So which answer is that? H. So when you're on your Chromebooks, what you're going to type is EDACJH. Okay, no spaces, no commas. Just like we've done the multiple response before. Okay, you're going to type it in that order. Okay. All right. Let's see. That was Lisandra's pick. So, Angelica, you get to pick the next one. 24. So the next one in line here. All right. The fill in the blanks, there's actually going to be 2 fill in the blanks, and you're going to have to fill in multiple blanks. Okay? So what we probably did was these ones up here that were verify. I don't know where they were at. These ones that were verify, we turned some of those into fill in the blanks. Does that make sense? But we do a line, give you a blank line, do a line, give you a blank line. So you have to figure out how to get from one line to the next. Is that okay? Hopefully that helps you. It's meant to help you, not to hurt you on the test. Okay? All right, so this one was our 24. All right, so all I have to do is figure out what to replay or what's happening here. So what do you see happening in this line right here? The cosines cancel. So I would write cosine squared x plus sine squared x. And then I should check to make sure I can get to the next line, right? So what's cosine squared plus sine squared? 1. So we should have gotten what's correct there. Okay. All right. Kevin gets the last individual pick. So Kevin, which one do you want? 17. All right, let's back it up. See if I can find 17. So, all right, that's 15, 16, 17. Is that the right 17? Make sure. Is that right, Kevin? Looks about right? Okay. Just want to make sure I'm doing the right problem. Okay. So it looks, okay, so I have to do the, difference of cubes factoring. All right. So I'm going to keep the cotangent x minus 1 in the denominator. And I know I've got to go from a binomial and a trinomial. What sign are we going to start with? Negative. What are my other two signs? Positive, positive. It always ends in a positive. All right, we're going to take the cubed root of the first term. What's the cubed root of the cotangent cubed? Cotangent x. What's the cubed root of 1? 1. Okay, then we ignore the original and we square this first term, so we get cotangent squared x. We square the 1, we get what? 1. And then we ignore the sign, multiply together for the middle, we get? What do you know? Isn't it that? You could probably forget how to do the cube factoring and figure out what to write down, because what's going to happen, what should happen with these guys? Cancel, and I get the answer. So if you have forgotten your cube factoring, you could still beat the problem by writing down the denominator and writing down that next to it, right? I wouldn't know the difference grading your test. All right, we get to pick 3 more as a class. So what else do you guys want to see as a class? I'm not doing all of them because not everybody had the study guide done. I gave you all of Friday, so I don't kind of feel sorry for you. All right, nothing else? We don't want to see your last 3? 8. Lauren says 8. So let's go up to 8. Make sure, is that the right 8? Yeah? Okay. All right, I'm going to turn things into sines and cosines when I don't know what to do. Okay, in fact, first of all, let me tear that apart a little bit. Cosecant of beta, cosine of beta, and this is the same as saying 1 over cotangent of beta. There's a lot of ways I could do this, okay? What's the same as 1 over cotangent? Tangent. And that puts it all on the same level, so when I start turning it into sines and cosines, everything's kind of in the right place. All right, what's another name for cosecant? 1 over sine beta. Cosine just going to hang out the way he's at. And what's another name for tangent? Sine beta over cosine beta. What happens? Cosines cancel, and what's left? 1. That would be a good multiple choice question. Okay. All right, we get to pick 2 more. What else do you guys want to see as a group? I'd recommend probably number 5 doesn't look pretty. Let me do 5. I'm looking at the answer key here, so 5 looks like it's kind of nasty. All right. So we have to perform the indicated operation and use the fundamental identities to simplify it. So I am going to use fraction addition here. Okay? So I need my LCD. What do you think your LCD is? And times cosine, right? All right, so this is where we look at what's missing from the denominator. So what's missing in this first denominator? Cosine. So I'm going to multiply by cosine x. What's cosine x times cosine x? Cosine squared x. Remember, cosine acts like a variable. What's missing in the second denominator? 1 plus sine x, meaning I'm going to have to FOIL. So what's 1 times 1? 1. 1 times sine x is, how many do I have? 2. So 2 sine x in the middle. What's sine x times sine x? Sine squared x. All right, I'm going to rearrange it so you see it. You don't necessarily have to do the rearrangement, okay? So I'm going to put my sine and my cosine together. So cosine squared x plus sine squared x plus 1 plus 2 sine x. Our goal is to get this as simple as we possibly can. What is cosine squared plus sine squared? 1. And again, I'm showing every little step on this one, okay? More for your benefit. Okay, what's 1 plus 1? 2 plus 2 sine x over 1 plus sine x times cosine x. I'm going to bring my work up here. Should probably have equal signs on all this, huh? All right, what can I factor out of the numerator?
1 cosine.
Can't I take a 2 out of the numerator? What's left behind then? 1 plus sine x. Why did I take out the 2? What was the benefit of doing that? I can now cancel the 1 plus sine x, so I've got 2 over cosine x, and I don't leave it in the denominator. What's 1 over cosine x equal to?
2
Yeah, 2 secant x. Alright, you guys get one more. Let me see if I can find one that was on the uglier side. We did 14, right? Yeah, we haven't done 16 yet. That one looks kind of nasty. I'm assuming we're okay on the solving the unit circle ones for the most part. It's the verifying ones that are going to be uglier. Let's look at, this is my recommendation, is that we look at 16.
16.
So Lauren says 16. That one. Okay? Because this isn't one of the identities we use very often, but it is going to be on the test likely. So you want to be ready for it. Okay. So, if you're looking at your cofunction, not the cofunction, it's the even odd identity. So it's the last window, the last column in the last window. And guys, I expect you to be looking at the windows during the test. That's okay. Okay, as long as you're not looking down at your neighbor's paper, you're looking up at the windows, that's fine. Okay? So, cosecant, what happens with the negative sign? Does it go away or does it come out front? It goes out front. So I really have 1 minus cosecant theta. What about the cosine? Does it go away or go out front? Goes away. So cosine theta. What about cotangent? Does it go away or go out front? Out front. So 1 minus cotangent theta. I don't have any squareds. If I start trying to multiply by a conjugate, it's just going to make it weird. Let's try turning things into sines and cosines. That's kind of our last resort, but sometimes that helps. So I'm going to go 1 minus, what's another name for cosecant in terms of sines and cosines? 1 over sine theta. Okay, what a cosine is just going to stay cosine. What's another name for cotangent? Cosine theta over sine theta. I'd like to get rid of sine in the denominator. So we're going to multiply by sine over sine. So really what I'm doing is multiplying by sine, don't write it down, over sine. Really what I want to do though is distribute that. So I'm really multiplying everything by sine theta. Now write that down. Multiply everything by sine theta. Okay, so this is what's really happening. I'm really multiplying by sine over sine because that's really like multiplying by 1. Okay, but I have to distribute it in. I'm going to erase this part. Okay. So sine times 1 would just be sine, right? What happens here? Cancel, so I've got minus 1. Sine times cosine is just going to be sine times cosine, so sine theta, cosine theta. What happens here? Cancel, so minus cosine theta. All right, look at what you've got. What could we do to change it? And what operation could we get or could do to get rid of something maybe? The cosines don't cancel, but what can we do with them? Starts with an F. We can factor them. Good. It's the greatest common factor factoring, isn't it? So I'm going to take out the cosine theta, and I'm left with sine theta minus 1. What happens now? We can cancel something. That's a lot of fun to cancel things. All right, what's 1 over cosine equal to? Secant theta. Okay. So again, did we get what we wanted? Yeah, but all those steps in between are what you need to show me for your work. Okay. All right, so that's where I'm going to stop because that's as many as we earned. Let me see. I would be ready. Let me flip back through really quick and see. Oh, the adding one? The one where we added the stuff together? Oh, it was 5, right? That one's going to be fill in the blank on the test. Okay, so be ready for that. It's a little bit different. No, actually. Yeah, there's a little bit of a tweak in it. Okay? And then, let me see if we can find the other fill in the blank. Let me see if it's like this fill in the blank that was there. So I'd make sure you knew your steps on that, particularly. Tangent. See what this one was like. No, it's not like that one at all. Tangent alpha. Secant alpha. It's similar to that. So it's kind of like this one here is the other fill in the blank. Okay? They don't give you, they give you the beginning, they don't say equal to, and they give you the end. Okay, same with the other, oh, the other one's not quite the end, but it asks you to simplify. Okay? And there's only one where you have to put the steps in order. Okay? Let me see the put the steps in order ones again. See if I can give you a bigger hint as to which one. I'd make sure, I know we didn't go over it, but I'd make sure I could do that one right there. I don't know what number is it on yours. 20? It's 22? That one's 22? Okay, so I'd make sure you could do 22. So I'd make sure you have that figured out. I think you've got an answer key, right? So you could figure that out from the answer key, hopefully. All right? If you want something stamped, you can come and see me today. All right? Corey, which one do you want me to do? 12? Okay. Let's look at 12. Both videos will go up, and then I'll show you what else I have up there for you. Okay? I don't remember what they did. I didn't save it. So I can maybe tell you, but I might not remember. So that might not be reliable. All right. Let me find my answer key real quick here. Okay, so we're looking at number 12. Alright, so for this one here, probably what I would do is I would use my Pythagorean identities to start doing some replacement on here. So I'm going to choose to replace this one in the back. So again, you should be using the windows. It's okay to look up at the windows. It's not okay to look down at your neighbor's test. Okay, so up at the windows is fine. What can I replace sine squared with in the Pythagorean identities? 1 minus cosine squared. And I chose to replace sine over cosine because look at my answer is in cosines. So I want to get rid of the sine. What are we going to do with this negative here? We're going to distribute it in. So we've got cosine squared beta minus 1 plus cosine squared beta. What's cosine squared beta plus cosine squared beta? 2 cosine squared beta minus 1. You should show me every little step. That's where your points are coming from, right? Because I give you the problem and the answer. You have to show me the work in between and how you get there. Okay? All right. Corey got one. Abel, which one do you want?
Number
18? 15?
Yeah.
That one? Okay. So if you notice on this one, it breaks off a cosine cube. So that's how I would probably start it. I know I've got cosine something, sine squared, and cosine cube breaks off at the end. So how do I get back to the fifth? Well, yeah, so it's going to be a squared on that cosine, and I'm going to try to work with it from there. It wants me to go into all signs, so I need to change this cosine into sines. Probably going to use the Pythagorean identity. So what would I put in there for the Pythagorean identity? 1 minus sine squared. Okay, and then look at what I do. I leave the cosine cubed on the outside. I'm going to distribute this in. So what do I get when I distribute in? To the fourth x, and then cosine cubed x. Again, it's the work. Did we get what we wanted? Yeah, the work in between is where I'm going to get your points from. All right, Tyler, which one do you want to see? 23. All right. So on this one, there may be more than one way. I think there's only one way to do this one. I think on the other one there were two ways to do it. What you want to do is you want to start with this side and go to this side. Okay, so what would my first letter choice be? What letter choice is that? Anybody see it? E, right? So you would start with E. If it was me, I would probably be writing it like that on my paper, okay? I know I've got to end with whatever this one is, right? So I've got to figure out what goes on in between. And just kind of glancing at my answers, it looks like I've got to get a secant appearing somehow, okay? Before I do that, though, I got to get rid of this tangent to the fourth. So I would probably factor that. Okay, so let's try factoring it and seeing if we can find a letter choice that matches. So what's this? It's different to squares, so what's the square root of 1? What's the square root of tangent to the fourth? And then what do we have to do for difference of squares? A plus and a minus. I'm going to go minus and plus. Now look at your answer choices. Which one is that? That's D. Okay, so now I've gotten rid of this one and I've gotten rid of that one. All right, so from there, I've got to do some replacement of some kind. Okay? Looking up at your Pythagorean identities, what is 1 plus tangent squared? That one's secant squared. So it looks like I've got a couple that have just a secant squared, right? Look at, we're trying to confuse you right here. Can 1 plus and 1 minus be the same thing? No, it's definitely not I, right? I would probably get rid of that one because I've identified that that's wrong. I need to replace this tangent because it looks like everything, it has to go into secants, right? Our answer's all in secants. So let's try to replace that tangent with something. So what can I put in for tangent squared? I can do secant squared minus 1. Again, you're using your posters, your identities that are up on the walls. Is that one of our choices? Which one? A. All right, and then what am I going to do with this negative? Distribute. Again, you're showing every tiny little step, okay? So I should now find one. This is 1 minus secant squared theta plus 1 times secant squared theta. Which one is that? It's letter choice C. So I've done A and I've done C now, okay? What do I get when I add 1 plus 1 together? 2 minus secant squared theta times secant squared theta. Is that one of our choices? It's J. Okay. All right. That's not the end yet, though, right? What do I still need to do with this thing? Looks like I've got to distribute. So 2 secant squared theta minus secant to the 4th theta. And what's that one? H. So now, if you were typing your answer in, because I know we didn't do one that way this time, okay? If you were typing your answer in, you would type in EDACJH. No spaces, no commas. Okay? All right. Bryce, you get a question. 16. Okay, I'll go to 16. What's wrong, Julius?
Where did you get the A? Where did you get the 1 minus?
This?
No, the 1 minus before.
This?
No, on A.
Here?
Yeah, how'd you get that?
I just dropped this down. I was only replacing the tangent. Okay? All right, I'm going to 16 now. All right. So on this one, you have to use your even and odd identities, which is the third window, the last column. Okay? So I'm going to work with the left side. When I see a cosecant, do I keep the negative or does the negative go away? Keep it. So 1 minus cosecant theta. What about cosine? Do I keep the negative or does it go away? Goes away. So cosine theta. What about cotangent? Do I keep it or does it go away? Keep it. So negative cotangent theta. All right. Unless it's like a 1 minus something or a 1 plus or like a trig plus 1, I wouldn't probably try to go to conjugates. If I've got 2 pieces of trig down here, I'm going to change everything into sines and cosines. Okay? So I'm going to go 1 minus, because if all else fails, I can always put it in sines and cosines, and I can simplify from there. Okay? So what's another name for cosecant? 1 over sine. Cosine is going to stay the way it is. And then what's another name for cotangent? Cosine over sine. Okay. I am going, no, don't write this next part down, because I'll tell you when to start writing again. I'm going to try to get rid of that denominator, okay? So that means I'm going to multiply top and bottom by sine theta, right? Because that's like multiplying by 1. So really what I have to do, though, is distribute that over the whole thing. Here's where you start writing. So it really means I multiply everything by sine theta. Does that make sense? So I'm trying to get rid of that fraction. Okay, so if I distribute that in, I've got sine theta. What happens with these signs right here? They cancel, so minus 1. I've got sine times cosine. And then the sines cancel, so I've got minus cosine theta. That says cosine theta. All right. What can I factor out of the denominator? I could take a cosine out, so I've got sine theta minus 1 over cosine theta. What's left behind? Right? Sine theta minus 1. What happens? I cancel my sine thetas, minus 1s. I'm left with 1 over cosine theta. What does that turn into? Secant theta. All right. Cody, which one do you want? 17. All right, so on 17, we're going to use cube factoring. Okay? So cotangent x minus 1 is on the bottom. I'm going to go into a binomial times a trinomial. So what is what's my sign that I start with? Minus. What do my other two signs have to be then? Plus, plus. What's the cubed root of cotangent cubed? Cotangent. What's the cubed root of 1? 1. Then I'm going to square the first one. So square the first one. What do you get? Cotangent squared. We're going to square the 1. What do you get? 1. And then ignore the sign and multiply the 2 together for the middle. Big hint! Isn't this and this the same? Every time you see the problem, it's going to be the same. Okay? And then the denominator ends up canceling. Am I going to know whether you just write this with the denominator in front or you actually factored it? Probably not. But you need to show me the step, right? And then cotangent squared x plus cotangent x plus 1. It's probably not going to be a cotangent. I'll probably pick on something else for the test. But it could be any of them, right? And you do that with it. All right, Julius, you get one.
You got
14, sure. All right. So 14, we're verifying again. I do see a denominator with a something minus 1. I'm going to choose to use this side first, and I'm going to multiply by the conjugate. So cosecant alpha minus 1, and I'm going to choose to multiply by the conjugate. What is the conjugate? Cosecant alpha plus 1. Good. All right, I am not going to distribute the numerator. I'm going to hope that something cancels. So I'm just going to leave it the way it is for now. I can always distribute at the end if I have to. The other clue to that is, look at, don't I have this now in my numerator? So I'm hoping my cotangent will go away. All right, in the denominator, we set up conjugates. So how do I FOIL those together? What do I really do? First and last only. Good. So what's cosecant times cosecant? Cosecant squared alpha. And then negative 1 times 1 is? Negative 1. Good. All right, that looks awfully Pythagorean to me. We got some squared. So what is the same as cosecant squared minus 1? Cotangent squared alpha. Cosecant alpha plus 1 in the numerator. All right, what can I do? I can cancel the cotangent. The cotangent's gone and I can get rid of one of these, right? So I'm left with the cosecant of alpha plus 1 over the cotangent of alpha. Is that what we wanted? Yeah. Yep. So we've got it. Remember the steps in between. This is what I'm checking for your points. All right, we good with 14? All right. Jimmy, what do you want to see? 5? All right. This one on the test is going to be fill in the blank. So we're going to give you some of the parts, and you're going to have to try to tell us how you get from one step to the next. Okay? At least you'll have that to help you out. The idea is to help you out. I think this is the one where it had, you know how I had the one problem when you numbered it A, B, C, D? This is that problem. Because you have 4 blanks that you're going to have to fill in. So we give you a line, you do a line, we give you a line, you do a line, kind of thing. Okay? Alright, so the first thing I'm going to do is, I'm supposed to perform the indicated operation. I'm going to get a common denominator. So what's my common denominator? Yeah. It's got to be whatever's there, right? Because I wouldn't circle anything if we went back to our circling method, right? We'd underline both of them. Okay. What is missing from this first denominator that's in the common denominator? Cosine x. Okay, so I've got cosine times cosine is cosine squared x. All right, what's missing in the second denominator? 1 plus sine x. And we are going to FOIL. So it's 1 times 1. Good. 1 times sine is what? Sine. How many of those do I have? 2. So I'm going to have 2 sine x. Sine times sine is sine squared x. All right. I'm going to show the work of rearranging it. So I'm going to show my commutative property. So I'm going to show you every little step on this one. So cosine squared and sine squared I'm going to put up front. So cosine squared x plus sine squared x. Remember, I'm giving you fill in the blanks. You're going to have to follow my line of thought, right? Not necessarily your own to get the blanks filled in correctly. All right. What's cosine squared plus sine squared? Look up at the Pythagorean signs. It's 1. So now you have 1 plus 2 sine x over 1 plus sine x cosine x. What's 1 plus 1? 2 plus 2 sine x over 1 plus sine x cosine x. Alright, what is your greatest common factor in the numerator? 2. I'm going to take that out. 1 plus sine x over 1 plus sine x cosine x. Why was it good to take out the 2? Yeah, we can cancel those. So now you've got 2 over cosine x. And you don't leave it like that, right? We have to get this out of the denominator. So how do I get it out of the denominator? Nope. What's 1 over cosine x the same as? Secant x. You turn it back into secant. All right, Paul, what do you want to see?
21.
21. Everybody got what they want on this one? All right, I'm going to go to 21. Let me just do this. All right, we are going to, you need your unit circle for this, okay? You will get to use them on the test, so make sure that you have it with you tomorrow. Just make sure there's nothing extra on it or I'll take it away because I'm going to check it tomorrow. All right, I want to get everything off the trig first, so how do I move the square to 3 over? Add it, so square to 3. How do we move the 2 that's in front over? Divide it, so square to 3 over 2. Alright, I need to find, is sine the x value or the y value? Y value. So I need to find everywhere on the unit circle where the y value is equal to square root of 3 over 2. So I'm looking for this to be y. So where does that happen? What radian measures? Pi over 3. Where else? 2 pi over 3. Everybody okay with both of those? All right. How do we move the 2 that's in front of the x over? Divide it or multiply by 1/2. So you've got x equals pi over 6. Okay. X equals, what happens with these 2's? Cancel. So we get pi over 3. All right. Everybody got it? Sorry. I was going to flip back through and see what we hadn't done yet. That last one's pretty easy. You guys got most of these in here. I think they did that. They did that one during second or during first. They did 8 during first. They did this one during first. 6 was done during first. They didn't do the factoring one. Those ones are more solving. I'd probably, because you guys get one more pick. They didn't do this one. They didn't do 13. Okay, but that one isn't terrible. I know this one's on the test. So I would either pick 13 or 22. So what do you guys want to do? 22 is almost identical on the test. I think I may have swapped maybe turned the tangent into a cotangent or something, or turned the cosine into a sine or something like that. So it's very similar. There's actually 2 ways to solve this one, I think. So I'd say I think that it's more likely this one than it is this one on the test. So I'd be ready for this one. So let's start by, it looks like I'm going to start by trying to I'm going to choose to turn things into sines and cosines, okay? Instead of Pythagorean identity. So let's do, I'm going to work with the side first. So what would my first step be, actually? Wouldn't I just write the original down? Yeah, so which letter is that? B. So I would start with B. Okay. All right. And then what am I going to put? I'm going to change the tangent into sines and cosines. So what would I write for that? Sine x over cosine squared x, and then still times cosine squared x. So what letter choice is that? That's G. All right, so I've gotten rid of B and I've gotten rid of G. All right, what happens next? Cosines cancel, so my next line would just be sine squared, because it's not going to show you the canceling, right? So what's sine squared x, what letter? F. But that's not my answer. What do I have to turn sine squared into? Yeah, and that's using your Pythagorean identities, right? So, and that's answer choice C. So you would type in B, G, F, C. And you have to type it in the right order in order to get it right. Okay? There is another way to do it, isn't there? What is it? Do we turn the tangent into secant squared? Is it this one? Next? I don't know if it goes where it would go. Oh yeah, you could do that next. You could do it, you could go that one next, and then it would be this one, right? No, you have to distribute in first. It would be this one, so it could be B, H, D, E, and then C. So it would actually be longer to go the other way. Okay? Alright, that's where I'm going to stop, because that's what you guys earned by doing your assignment. If you have something that you want stamped, you can come back and see me. I'll be happy to stamp it. Okay? And then the rest of the period, you should be getting ready for this test, right? What was I going to say? So how many more times should you do the study guide? At least 3. You should probably finish it to begin with, right? Oh, that's also what I was going to show you. If you look in haiku, okay, so look in haiku with me really quick. What I did, anticipating that we wouldn't have this done, if you look, I put a link to the resources for last year's test, because I didn't really change the study guide a whole lot, actually, for like the last 2 years. There's a few questions we've pulled out over the years, but all the questions are there. They just might be in a different order, okay? So it takes you directly to the link of a page where there's some videos, okay? There's a complete key with the work, okay? Again, the numbers might be a little bit different, but the problems are all there, all right? And then there's another study guide video. So if you want the video version, you're probably going to find something. It might not be the right problem numbers, but you might find something there to help you out, okay? And then I will also post the videos from today. All right, sound good? All right, if you want stamps, you can come back and see me. I'm going to hit the stop button on this thing, and I will be happy to